So continuing on here with our different reaction types, this is part 5 to chemical reactions. So we are dealing with neutralization reactions, also called acid-base reactions. So neutralization reactions occur when an acid, which is most compounds that start with an H, and a base, most compounds that end with an OH or begin with NH4, react to form a salt and water. So neutralization is actually just a special type of double replacement reaction, but we'll get into that in a bit. So OH is what's called a hydroxide group, and NH4 is the ammonium ion, which is a polyatomic. General form is an acid plus a base, so these are our reactants, formed to produce a salt, or yield salt and water, which are our products. The general form with compounds is HX, meaning a nonmetal attached to a hydrogen, with a hydrogen at the beginning, plus a metal with an OH hydroxide group, reacts to form the metal and nonmetal, so your ionic salt, plus water. So the acid is the hydrogen paired with the nonmetal. Our base is the nonmetal paired with the hydroxide. These react, resulting in a metal and nonmetal coming together, M and X, to form a compound that is salt. This is an ionic compound, not like table salt. Salt is in the type of ionic compound that is produced from a neutralization reaction. And H2O, because when you combine H and OH, so HOH, if you look at that, you have 2 hydrogens and an oxygen. So that is just water. Okay, so sulfuric acid is used to neutralize calcium hydroxide as our example. So I'm going to skip the namings of acids for now, as we're going to cover that in a future lesson. But you should be able to handle the naming of bases because it's simply a metal attached to a hydroxide, which is a polyatomic. So pretty straightforward there. So H2SO4 plus CaOH2 produces CaSO4 and H2O. So calcium sulfate, which is right here, is our salt, and water is formed from this reaction. So again, this all needs to be balanced, which we can see with our coefficients in front of the water. And below that is also labeled with the A, B, C, D letters, so you can see that the swapping of the element in the second position, so in this case our polyatomics, have swapped. Second example, phosphoric acid helps to neutralize the compounds that cause rust, such as iron 2 hydroxide. Again, not concerned about the naming of the acid yet, but you should know the base is iron 2 hydroxide based on our naming rules. So the nonmetal from the acid and the nonmetal from the base will combine to give us our salt, which is Fe3PO4 and our water. Again, this needs to be balanced. It's already balanced for you. So you've got 2 parts H3PO4 plus 3 parts FeOH2 yields 1 part Fe3PO42 plus 6 parts of water. Neutralization is just a special case of a double replacement reaction. So in double replacement is with an ionic compound and an ionic compound, giving us 2 different ionic compounds. This is an acid which is kind of ionic. Technically it's non-metals, but we treat it as if it's ionic here. Paired with a base which is ionic, which gives us a salt, which is an ionic compound, and water. But the end result of an acid-base reaction is always the salt plus the water. So again, some practice problems for you to try before moving on to the next video.